So let's take a look at the declaration of the request handler class, which implements the request handler component. So in the declaration, first of all, let's take a look at the necessary libraries that are needed by this class, and those are strings. So it's necessary to use strings in C++. And then we have this JSON.hpp, and it's used by C++ to manage JSON, since JSON is necessary for HTTP communication. So this library helps us to manage JSON programmatically in C++. And then the last library that is included is curl, and curl is used to make HTTP requests programmatically. So C++ relies on this library to make HTTP requests programmatically. And then some of the public methods declared in this class is a method to make post requests to a given URL, and a get method to make get requests to a given URL. And we also have a constructor and a destructor, and we will see how they are implemented in the implementation file. Now coming to the private members of this request handler class, we have a pointer of type curl, and we will see its purpose in the implementation file. And then we have a static member. So static members, they basically belong to the class. They cannot be instantiated, and we will see its purpose. We will also see the purpose of this static member in the implementation file. So let's next move on to the implementation. Now let's take a look at the implementation of the request handler class. So the implementation of this class starts with the the first thing that is implemented is the constructor. So the constructor of the request handler, it initializes a libcurl session. So in order to understand how to initialize a libcurl session, the documentation of the libcurl suggests that the first thing is that we acquire a reference to a valid libcurl section by invoking this function curl _easy _init. So this is going to initialize a libcurl session and return a reference to that session, and the reference is stored inside this curl variable, which is a private data member of the request handler class. We have already seen this in the declaration. So if the initialization was successful, then we're going to have a valid reference inside this variable. Now if the reference is invalid, or if something goes wrong, then we're going to have a null pointer in this reference. If there is a null pointer in this reference, then this statement, this condition will evaluate to true, and this statement will be executed, and an exception will be thrown, a runtime exception, which indicates that the resources were not allocated in this case. So the second thing that we can see is the implementation of the destructor. So the destructor, it basically releases the resources that are occupied or acquired by the libcurl. Again, and this is suggested in the documentation, that we must manually release the resources which are occupied by the libcurl, since that will not be done automatically. So we must do it manually to avoid memory leakage. Now let's take a look at the implementation of the post method. Now the return type of this method is a string, so the response will be returned as a string. So the the parameters of this function are it takes a reference to the URL and a reference to the a reference of type JSON, which is going to contain the payload for the request, and another reference of type string, which is going to point to the access token. Now, the first thing that we do in this code is that we make sure that the curl handle or the curl variable is not null. This is necessary because if we try to dereference a null pointer, we are going to have a crash. Now the next thing that we have here is a variable of type string, and this is going to hold the response from the server. And the next thing that we do is we convert the JSON payload into a string. Since the libcurl won't understand JSON as such, so we must convert this into a string. So this statement is to convert the JSON object into a string. Then the next, before explaining these similar looking set of statements, so the libcurl, a session with the libcurl follows follows 4 basic steps. The first thing is to initialize a session with the libcurl, which we have already done inside the constructor. Second thing is to set the request options, where we specify what type of request we are making, whether it's a GET or a POST request, what is the URL that we are trying to access, what is or any additional parameters that are required. So in order to set those options, the documentation suggests we use this curl _easy _set opt, which stands for set options. So we pass the reference to the curl handle, and then we specify the type of option we are setting, and this the first statement basically specifies the URL. This is basically the parameter, the reference to the URL, but it's a C++ type string. We must convert into a C type string since libcurl won't understand C++ type strings. So the the strings must end with a 0 byte, which basically are the C type strings. So the next statement that we have here, it specifies that we are trying to make a POST request, and the next statement specifies the POST fields, which is basically the JSON payload, and we are also converting this into a C type string. The next statement specifies what to do with the response, how to process the response coming from the server. And we are and for that we are passing a reference to a reference of the function that should process the response from the server. And we will look at the implementation and details of that function in a short while. And after that we have another option setting which specifies where to store the response from the server. And the response, once we have set up the various request options, it's time to set up the headers. An HTTP request has headers and the payload. So the libcurl documentation suggests that header should be maintained as a linked list. The headers should be maintained inside a linked list, and the reference of that linked list should be passed to the libcurl. So this is what we are doing in these lines of code. So this is a declaration of a pointer, and the data type of the pointer is this struct curl underscore s list, which is defined in the libcurl library, and we are initializing it to a null pointer, since that is going to be safe for us. Then we're going to attach a node to this headers pointer. So in order to attach a node to this headers pointer, we're going to invoke this function curl underscore s list underscore append, and we're going to pass the headers pointer to this, and the HTTP header that we want to send with our request. So in this we are specifying the content type header. So the syntax for that is pretty straightforward: content type and colon application slash JSON. And the second header that we need to specify is the access token. So if we have a token inside the token reference which we are receiving as an argument, so if the token is not empty, if we have an access token, then we must attach that to the request. So in order to do that, we are going to append that to the linked list of headers. So we're going to call the same function. This time we are going to pass the authorization header, and this bearer, this specifies the authentication scheme. So since we are dealing with the token based authentication scheme, so we are going to specify accordingly. And then this is simply a concatenation between strings, and this is pretty simple in C++. So this after the bearer there is a space, and then we are appending the token, and then we are converting the whole string inside these two braces into a C-type string, and this will be attached to the linked list as a new node. And after that we have we are passing the reference to the first node of this linked list, which contains headers to the libcurl session. After that we are finally going to perform the post request to the given URL. So in order to do that, we are going to invoke this curl underscore easy underscore perform function, and this is the third step of the libcurl session. The first is to initialize, second is to set options, and the third is to perform the request. So once the request is performed, we are going to get a response code, and this response code is going to tell us the status of our request, what happened to our request. Next thing is to check if the request was unsuccessful. If the request is unsuccessful, then we must throw a runtime error. So if the response code is not equal to curl underscore OK, which is basically 0, if the response is equal to 0, then the request which is a non-zero value. If the request was unsuccessful, then we're going to get a non-zero value inside as a response code. So if that is non-zero or that's not equal to curl underscore OK, then we're going to throw a runtime exception, a runtime error, and we are going to specify the reason, and the reason is curl post request failed. Plus we are going to append the string version of the error. So this is going to give us a human readable form of the error that occurred while performing the request. Now if the request was successful and this statement does not evaluate, this condition does not evaluate to true, then we are going to return the response data. Now you might have noticed that I have skipped to explain this line of code. So this line of code is to free the resources that are acquired by the headers. Since they were acquired at the runtime, so they will not be automatically released by the C++, or even when the object is destroyed, these resources will still persist inside the memory unless the program is running. So we must release these resources in order to avoid memory leakage. And this is also suggested by the libcurl documentation as the fourth step of a libcurl session. So everything fine, we are going to return the response data. So the next thing is we're going to look at the HTTP GET request. So this is the implementation of the GET method declared in the declaration of the request handler class. So the response type, and this method is very much similar to the post method with some slight changes. So I'm going to explain briefly the implementation of GET method. So it takes a reference to the URL and a reference to the query parameters, which should be attached to the end of the URL, and a reference to the token. So let's take a look at this statement here. So this constructs the full URL. So it's going to append the query parameters that we're getting in this query params reference to the URL. So this here is a conditional statement. It checks if the query parameters are empty, then attach an empty string to the URL. If they are not, then attach a question mark plus the query parameters. And then the other things are very similar as were explained in the post request, except we're specifying that it's a GET request, and that's it. Now let's take a look at the request handler write callback. As we have already seen this method, this is also specified in the libcurl documentation that how do we control the response which comes from the server. The response from the server comes in chunks, so we can control what to do with that. So if we do not specify a write callback function, if we do not specify our own method of controlling the response, then the default mode is activated, which directs the response from the server to the standard output stream. But we do not want that to happen, so we are specifying this function. So in our case, we want the response to be accumulated inside a single variable which we can return to the caller of the request, post or get. So that's what we are doing in this case. So even the signature of this method should match the signature as recommended by the libcurl documentation. So we must have these parameters and the same return type in order to avoid problems. So this is a void pointer, and it represents the chunk of data received from the server. And the second parameter is it represents the size of a data block inside the chunk, and this represents the number of data blocks inside the chunk. and this refers to what will be what we are going to have access to after the request is successful, or simply this is going to contain our data. And it's also a void pointer. So void pointers are basically generic pointers, and we must convert them to intended type. So the first thing is that we calculate the total size of this data block, and this is the size of a single block and the number of blocks inside the receiver chunk. The second thing is that we convert this user data, which is a void pointer, we convert this into a string pointer and store the reference inside this response variable. And this is the syntax for casting the pointer into a string type pointer. And it's a static cast, which means the types will be cross-checked at the compile time to improve the type safety. The third statement of this function is that now we are going to append this the data chunk received from the server to this user data. Now, since response is now a string pointer, so it's going to have access to all the string class functionalities in the standard library of C++. So this append method is defined by the string class in the standard library, and we are passing the pointer to this data chunk, to the first element of this data chunk, and the total size of the data chunk. So this is one of the ways to append a string to concatenate two strings. After that is successful, now since we saw the implementation of the request handler class in detail, now it's time to test. So right on your screen you can see the test. It is the test file to test the request handler class. So the first thing we do here is we are instantiating the request handler class. So handler is our object. Now this file has two sections for testing. One is to test GET request and other is to test POST request. Now the first section here, it is used to test the POST request, and the second section, which begins here, is used to test the GET request. So the first thing in the testing a POST request, we are specifying an authentication URL, which is a string. And in this case we are going to we are going to send the client credentials, our client ID and the client secret provided by the Deribit tester. We are going to pass them to the authentication endpoint of the Deribit API, and in return we should get the access and the refresh token, which can be used to access the authenticated endpoints as we do the order execution later on. So this is the endpoint for authentication, and this is how we craft the JSON payload, and the various parameters and headers are specified. So again, this is taken from the documentation of the Deribit test, and the various parameters have been set here. Now the second thing that we do is we are actually making a POST request using the object of the auth handler class, which is the handler. So we say handler.post, and we pass the authentication URL and the authentication payload. And the response that we get from this method, we are printing that on the console. Now similarly, we are going to test the get request, and we have a URL, and we have some query parameters. In this case, we are actually retrieving the order book for BTC Perpetual, and we are making a get request and by calling handler.get, the get method of the request handler class, and we are passing the URL and the query parameters, and we print the response on the console. Now this all of this code has been placed inside a try block, since the get and post methods of the request handler class may throw an exception if the curl handle is invalid or something else goes wrong with the curl. So in case it throws an exception, we are ready to catch that and handle that exception by creating an object of type exception, which is a generic type which is capable of handling various runtime exceptions, and we are also going to print the message on the console using the ex.what went wrong. Having explained the testing mechanism, let us see this in action. So we are going to test the request handler class using this test file. So in order to do that, I'm gonna navigate to my command prompt. So let me navigate to the project directory, cd documents, cd Deribit trading system. So I have kept everything pre-built in order to save time. So this is the build directory, cd build, which has the executable. So this is the executable file which is going to test the request handler, test underscore request underscore handler.exe. So test request. Let's run this file and see what happens. Enter. So the testing is successful. So we have got the access token, and the refresh token, which it means that the post request is successful. So testing the post request, so we have got the access token from the server and the refresh token as well. And also the get request is also successful. This is the get request and this is the response from the get request, and we have got the order book for the instrument BTC Perpetual. So this is how the request handler class is implemented, and we have also tested it successfully. Now it's